Well, good morning, everybody. This is Jeremy Williams representing Garden City Ammonia Program and GCAPCoolcast.com, GCAP's online division. Today I'm going to bring you another Facebook Live and look at the applications of twin screw compressors and the applications of oil separators, impingement style with dual chambers, sometimes known as the wet and B side or the wet and dry side. Wet side also known as the A side. To help me out, we're going to be using one of our cutaways here at the school. And turning around in this application, we can see that this sky blue device that has the GCAP logo on it, there's the end cap of the main oil separator, which would be known as the B or the dry side. As we move this direction over here and look at the opening end of this cutaway, this side right here would be known as the A or the wet side. So we'll start off here and look at the compressor itself. That's this tiny device here. A motor's been removed where GCAP's logo is at. And this is a small machine. This is one we took out a few years ago, about 50 horsepower. If it was a 50 ton or maybe 25 tons, it was about a 20-degree application. But inside this opening here, the other side you can see open as well. Looking down in there, we'll see one of the two rotors on this side, and we'll see that when I start moving these rotors, they'll free spin either direction, and that's for another class, another lecture. But it'd be spinning in this application, and the primary oil injection port is right here. And that oil injection port, when it comes in, would be going through this distribution manifold through these rotors. And just to give you some idea, if this machine was moving, let's say 25 pounds of ammonia gas, we'd be moving anywhere from 50 to 75 pounds of oil, 8 pounds in a gallon. This little device here would be moving, 15 to 20 gallons per minute injected every single minute. Around. As we inject that ammonia into this machine, that oil separator that's underneath there would need to be doing that separation. Right here is the main discharge port, so all the ammonia gas and oil would be coming out of this machine and it'd be connected with the 90 to where my finger's going into this main discharge, and that discharge is coming around here, and Joe's helping me out with the light here. This would be coming down into the discharge port of this machine, and you can see when we get back in there, that discharge port comes into here. Frick was notorious for putting these things in some of their machines. I'm going to call it an oil manifold, oil distribution manifold. And there's a bunch of holes cut on the bottom side. We cut this apart so we could see the material that's in here. And all that oil and gas is going to be going through that back plate. You'll be able to see a dam back there. And as we continue on, these gases are going to keep traveling through this tank, go up and over the dam. And oil level would be relatively low, right where my hand's at when we look at the dual side glasses. And then hopefully the gases would come inside of this oil coalescer here, which some people call them coalescing filters. I like to call them coalescers. This has got one, and if there was any remaining oil that was left in there, hopefully drops out, and then this would be our discharge line leaving the oil separator, which would hopefully then take the dry gases back to an intercooler or maybe the condenser, depending on the application of system and designs. So that's a real quick little story about oil separation for the online students in the online division. And this machine also has an external heat exchanger oil cooler, and thermal siphon could be used. There's 66 tubes in there. And on this one, the ammonia would be on the tube side. And now Joe's going to put a light there, and I'm going to come over here to this side, and we'll be able to see that that light is shining through a couple of those tubes that he has in there, and be able to transfer that heat through the oil. This one is a counterflow system. The oil comes in on this side down here, comes out over here on this side, while the ammonia flows the opposite direction. I hope this was a beneficial podcast for you guys. This one right here was sponsored by Camco. And we couldn't do a lot of things without these guys. And they're one of the best in the country for sure. Appreciate the hats and Mike and all you guys. So let me give a little shout out to these guys. But Camco Lubricants has been used in selling the highest quality refrigeration oil of lubrication for over 35 years. They're the pioneer in all hydro-treated technologies that are out there. The Camco 717 series, which we have a couple of different jugs of the HT, and over here we also have their variation of what's known as the 717 SE. This is some good stuff. They've been working with OEMs and engineers for the last 35 years, and many of their lubricants today are actually used in all types of refrigeration application. If you guys are a customer at Camco, you know that you're getting the highest quality oil possible when these things are used. With their name, it means quality, reliability, performance, and efficiency. And again, my name is Jeremy Williams, representing GCAPCoolcast.com, Garden City Ammonia Program Online Training Division. A little introduction to twin screw compressors and oil separation. Till we get a chance to meet each other again, make sure you keep it in the pipes.